Hello everyone, my name is Leonardo and I'm going to present my path to system software engineering. The classic who am I slide, my full name is Leonardo Braço Passos. I work in Brazil at Red Hat by the VIR team. My main work is in the Linux kernel, trying to improve CPU isolation and real-time behavior. And I also have this side question improving RISC-V architecture code. In QEMU I have previously helped in improving live migration speed. If you want to find me by any way, use this handle here, LeoBraz, in those networks, and it should be easy to find me. Well, let's start first introducing what in my vision is system software engineering. System software engineering is responsible for developing the base of computer systems for general use, meaning operating systems, compilers, drivers, libraries, etc. And it tends to fit on this category general pieces of software that are not applications, also known as the low-level stuff. Usually, developing system software requires deeper level of understanding how the computer systems work, and usually I try to focus on the Linux kernel, which is the most interesting piece in my opinion. And that was my path. I mean, it was no straight line at all means. It all started, as for everyone, when we are children and we have something that we want to pursue. And when I was a child, I always wanted to know how things worked. Which means that I ended up disassembling a lot of objects at home and toys and try to look inside and try to perceive how does that work. To be honest, I was introduced to computers at 10 and they were amazing, but looking inside did not help me understand how they work at all. Then I tried to work as a trainee in this computer store near my home and try to understand how computers work. And there I got to understand how desktop computers were assembled and how to install operating system drivers and even do small PCB repairs, printed circuit board repairs. And it was great for a couple of weeks. And when I had more deep questions about how the processors work, about how the GPUs work, people were not quite interested on that. And they actually try to say that we don't know and we will probably never know because this is some company secret. And I was quite disappointed at this point at computers. So I ended up looking for something that I could understand better. And I started this course in industrial mechanics. I was a teenager at the time. And it was great because I learned how to create very useful things in steel and even draw 3D objects, and it would be very helpful today with 3D printers. But the main thing here is that I got a really good understanding of how complex mechanical mechanisms work. And a lot of new things that I get to know in this course, and I couldn't understand because I didn't understand electricity. So, I wasn't really sure about what to do for graduation. So, out of this curiosity, I ended up joining graduation in electrical engineering at the University of São Paulo in Brazil. And it was great because I got to understand how electricity is generated and how is used to perform useful things, how circuits work and how to use those circuits for control, automating tasks. It was very nice, a lot of things that I got to understand there about electricity. And I also got to try basic programming and even started using Linux as a user. And I also had this microcontroller programming class, which was awesome. Because of this course, I started a undergrad research in Linux plus real-time. At the point, I did not quite understand what real-time was, but I thought it was really cool. and it was on a small ARM board, 128 megahertz, 64 megabytes of RAM, and 512 megabytes of flash storage. And it was very small, but it was good enough so I could compile upstream kernels with real-time patch at the time, create new root file systems, and installing base tools for web development and for app development for the other researchers in the lab, so they could create like electronics that would measure something and send over the internet. And just for reference, that was around 2 years before the first Raspberry Pi release. At the time, this was quite new for the guys, and I was quite interested at the point. And then, as a trainee process for the end of my graduation, I joined this optical communications research and development company, which mostly helped me apply the things that I got to learn in the undergrad research. And it also improved my programming skills because I was there developing firmware. The fun part about this one is that I got to learn different technologies like optical communications, microelectromechanical devices, and photonic, which helped me understand how light in a fiber can help us achieve very fast internet connections, right? Like today, at the time they were not quite common here, but as of today, I understand they are an essential part in this, in our network. After that, I joined a company for doing firmware as an electronics engineer, and I learned a lot about creating electronic devices, PCB design, production of the PCB, the printed circuit board, and how to assemble the components on that. And it was quite interesting because I also got to learn more about system software since I was doing the firmware. And it was nice to understand how software interacts with the system and how the boot happens, how the firmware starts running. Because since there is no operating system to help us or even save us when we do mistakes, programming in those systems is quite challenging. And it's quite good to get to understand, because every bug that you have will be a big bug and you'll have to debug a lot, and in the process you learn a lot. So it was quite interesting. At the same company, I ended up porting 2 whole products between platforms, 2 different processors, and modularize every software component. It was quite a challenging and interesting task. I ended up advocating for using embedded Linux in the next company's product, but the company ended up just rejecting this, and I ended up attending to this Linux device drivers course, which changed my career at this point, because I got to do this programming, this kernel programming, and it was amazing how code was clean and how code was well structured, and how the development process was. It was quite interesting. So at this point I decided to change my career and completely and become a Linux kernel developer and Linux kernel engineer. Which made me change company to this other company, which was needing this embedded Linux developer. It was great because I got to work with embedded Linux, but it was kind of boring because it was application development. And to be honest, even when we had to deal with hardware, it was too abstracted to be fun. And writing the applications was quite easy and boring because all the low-level stuff was already done. And even though it's quite important, it was not my thing. So I ended up moving to IBM in the Linux Technology Center here in Brazil. I worked with Linux on Power architecture, and to be honest, in the beginning it was quite interesting because I did not understand most of this stuff. I was under the impression that everything that I knew about computers was wrong at some point, and I ended up learning that microcontrollers and processors, like full complex computers, like server-grade computers, server-grade power, are quite different, and the server-grade computers use a lot more interesting mechanisms to speed up and to provide other features. In the end, I ended up learning a lot about computer architecture, and like the newest things that I got to understand were virtualization. I learned more about the kernel, privilege levels, how hardwares communicate like in a modern way, and instructions encoding, cache, MMU, and a lot of new stuff that was quite interesting. And I got to interact with the kernel community, which was quite interesting to talk to people across companies about a similar subject. Is quite nice. But every day, in the end, every day was a great opportunity for learning at this company. But at some point I decided to change to another company where I could learn more. And I joined Red Hat as a senior software engineer. My main work was live migration at the start, but I got to learn a lot about the Linux kernel. I ended up learning more about parallel programming and how the locks, the inner workings of the locks happen, and how real-time schedulers work and how CPU isolation work, which is also quite interesting. And even how is the kernel interface for live migration. I mean, it's quite interesting that you can just stop some virtual machine, and change computers with the machine running. It's quite nice. At this company, I also improved my interaction with the kernel community because, Red Hat is a reference, and I got to know a lot of the people that I would only meet by the mail list, so it made my job much easier. At the same time, working at Red Hat, I ended up starting a master's degree in computer architecture, and it was great because it helped me structure my understanding of how a computer system works, and even understand some rules of programming that only make sense if you have a deeper understanding of how the computer system we work under the hood. So it has been a quite interesting experience working in this master degrees, and by probably be about RISC-V because proposing stuff is much more simpler because everything in the architecture is open. Well, so far for me, system software engineering has been a nice career because it allows me to keep learning interesting stuff while I am working and proposing changes that those changes are able to impact a lot of users. And also, it's interesting to notice that my career path was never a direct line, and none need to be a direct line. But the thing that kept me going is that nothing that I ever learned was wasted. So if I were to give a tip about career here, would be pursue whatever you are thinking it's interesting and try to do your best because you'll probably go right. I mean, you'll probably be doing a nice work and people will want to get you. So I think that's it. I hope to be able to answer any questions in the chat down below. So thanks everyone.